Hello students, I hope all of you are fine and safe. So far we have completed 3 lessons. Now we are going to start the next lesson, the language of chemistry. Okay students, let's start learning. We use language to communicate with each other, right? Most of us know 2 languages. Some of us even know more than that. Without language, it is very difficult to convey the ideas. So, today we are going to learn the language of chemistry. Normally, the languages are built with letters, words, and sentences. But the language of chemistry is built with symbols, formulas, and equations. We are going to learn the language of chemistry from the basics. Let's start with symbols. Okay. For instance, imagine a boy whose name is Abhishek, but his family members and his close relatives call him by the nickname Abhi, which is the short form of Abhishek, right? Similarly, in chemistry, the elements are given with symbols. For example, the symbol of hydrogen is H. Earlier, the pictorial symbols were used to represent an element. Later, a Swedish chemist named Johannes Jacob Berzelius laid the foundation for the usage of alphabet as symbols of elements. This language underwent development gradually into its present form. Okay, now let's see the definition of symbols. A symbol is an abbreviation for the name of an element. Here, symbol is an abbreviation, right? Which is the short form of a name of an element. Let's see some examples. The symbol of hydrogen is H, the symbol of carbon is C, and the symbol of sulfur is S. Now, let's see how the symbols of different elements have been derived. Symbols of different elements have been derived in 3 ways. Let's see it one by one. Before we moving on to the first way, let's see some elements with their symbols. The first one is hydrogen, whose symbol is H. Next one is carbon, whose symbol is C. Then nitrogen, whose symbol is N. Then oxygen, whose symbol is O. Then fluorine, whose symbol is F. Then phosphorus, whose symbol is P. Now, among these symbols, what do you think is common? Yes, the symbols are the first letters of the name of these elements. So, this is the first way. The first letter of the English name of an element is assigned as a symbol for some elements, and it should be written in capital letter. Okay. Now, there are 2 elements named hydrogen and helium, both starting with the same alphabet. They have already given the symbol H for hydrogen. So what they did is they gave the symbol He for helium. Now, this is the second way. The first letter along with one more letter of the English name of an element is assigned as the symbols for some elements. Let's see some examples. For calcium, the symbol is Ca. The first 2 letters of its name is given as a symbol. Secondly, for nickel, the first and the second letters were assigned as a symbol. Now, for magnesium, the first and the third letter is given as a symbol. As you see, the symbol of magnesium is Mg. In case of platinum, the first and the fourth letter is used as a symbol. Its symbol is PT. Finally, for cobalt, the first and second letters have been used as a symbol, whose symbol is CO. Now we are moving on to the next wave. According to the first and the second wave, what will be the symbol for sodium? It should be S or SO or something like that, right? But that's not correct. The symbol for sodium is Na. How come? The answer is given by the third wave. That is, one or more letters of the Latin name of an element are given as a symbol for some elements. Sodium's Latin name is natrium, from which the symbol for sodium is derived. As you see, the first two letters of the Latin name of sodium is given as its symbol. Let's see some more examples. I have listed the English name and the Latin names and their symbols in a table. So I have listed 5 elements. Let's see one by one. The first one is potassium, whose Latin name is kalium and its symbol is K. The second one is iron, whose Latin name is ferrum and its symbol is Fe. The first two letters is assigned, whereas for potassium only the first letter is assigned as a symbol. The third one is gold, whose Latin name is aurum. The symbol is Au. Here also the first two letters were assigned as a symbol. The fourth one is lead, whose Latin name is plumbum. The symbol for lead is Pb. Here the first and fourth letter, the first and the fifth letter of the Latin name of lead is given as a symbol. And the last one is mercury, whose Latin name is hydrargyrum. Here the symbol is Hg. Here the first and the sixth letter were assigned as a symbol. Let's recall the ways from which the symbols of different elements are derived. The first one is the letter of the English name of an element. It should be a capital letter. Then the second one is the first letter along with one more letter of the English name of an element. And the final one is one or more letters of a Latin name of an element. These are the 3 ways. I hope you all understood till this. Now we are moving on to the second part, which is formulae. Okay, here I have the symbol of hydrogen and the formula of hydrogen. What difference do you observe between these two? Yes, in formula you can see a number in the subscript, right? A formula is written for a molecule, whereas a symbol is given for an element. Here in molecule, 1 or 2 atoms or more atoms also combines to form a molecule here, right? So by looking at the formula of a molecule, we can say how many atoms of an element are present in the molecule. For example, here you can see the formula for hydrogen molecule is H2. From this we can understand that 2 atoms of hydrogen are present in this hydrogen molecule. Let's see the definition of formula. The formula of a molecule gives the number of atoms of the same or different element present in the molecule. Okay, the examples are listed below. For nitrogen, the formula is N2 and it has 2 atoms. For Phosphorus, the formula is P4 and it has 4 atoms. For sulfur, the formula of a sulfur molecule is S8. Here it has 8 atoms. For chlorine molecule, it has 2 atoms. Finally, for ozone molecule, it has 3 atoms. Now, when we are talking about the formula, it has been divided into two. First one is formula of element and the next one is formula of a compound. In today's class, we are going to see the formula of elements. Let's see. When atom combines with one or two atom of the element, a molecule of the element is formed. Now, in these two lines, we can understand how a molecule of the element is formed. It is the combination of one or two atoms of the same element. Okay, it results in the formation of a molecule of the element. Now, the number of atoms contained in the molecule is called the atomicity of the molecule. So, here atomicity represents the number of atoms present in the molecule. Atomicity represents the number of atoms present in the molecule. Let's see some examples for atomicity. Okay, first we have nitrogen, in which there is 2 atoms, so it is named as diatomic molecule. The atomicity of nitrogen is 2. As you see, it has 2 atoms. The atomicity is 2. The next example is ozone. The formula of ozone is O3. So it has 3 atoms, so it is named as triatomic molecule. The atomicity is 3. As we know, the number of atoms contained in a molecule is called as atomicity, right? So here the atomicity of ozone is 3. Then for fluorine, it is a diatomic molecule. The atomicity of fluorine is 2. Then for phosphorus, the formula of phosphorus molecule is P4. So here, when the atomicity exceeds 3, they are named as polyatomic molecules, right? And the atomicity of phosphorus is 4. And finally, we have sulfur molecule, which is again a polyatomic molecule, and the atomicity is 8. Okay, finally we are going to see one more type of molecule. Here the noble gases are monoatomic. So what are noble gases? Yes, helium, neon, argon, xenon, radon. These are the noble gases, right? Why are they monoatomic? Atom of noble gases are inactive. They are self-sufficient, so they do not combine with other elements. Thus, they are monoatomic molecules. Okay, I hope you all understand till this. So, we have come to the end of this session. Let's see the summary. The language of chemistry deals with symbols, formula, and equations. The symbol is an abbreviation of an element. The symbols are derived in 3 ways. They are the first letter of the English name of an element, the first letter along with one more letter of the English name of an element. In the former, the letter should be written in a capital letter. And finally, one or more letter of the Latin name of an element. So these are the 3 ways from which the symbols of the elements are derived. Then the formula of molecule gives the number of atoms of the same or different element present in the molecule. And finally, the number of atoms contained in a molecule is called the atomicity of the molecule. So that's all for today's class. Let's see the assignment questions. The assignment questions are: what does the symbol of an element means? The next one is: name 3 polyatomic molecules. The last one is: give the atomicity of the following molecule. First one is helium, second one is hydrogen, third one is ozone, fourth one is iodine, and the fifth one is bromine. The answers for this question is given in this video. Kindly note the answers down in your chemistry notebook. Thank you, students.